morning students, welcome to this online class. So today students, we are again starting our online classes because of the prevailing pandemic situation. So as you have come to know that for the time being till May 3rd, your regular classes are cancelled. So that's why we have started our online classes. So please watch these things properly and practice carefully at home. Okay. So let us start. Then we were going. That means we are continuing from exercise 1.3. So exercise 1.3. So that's exercise 1.3. Okay. So students of class 9, please see these things carefully and practice properly. Okay. So let us start exercise 1.3 of our NCERT book. Question number 4 says that express 0.99999 in the form P by Q. Are you surprised by your answer? The teacher and class will discuss why the answer makes sense. Okay. So number 4. Let x is equal to 0.9 class number 1. So students, 0.999, isn't it? So 0.99999 means 0.9 particle number 1. So now, how many numbers are repeating here, students? How many numbers are repeating? Only one number is repeating, isn't it? You see, 0.9999, 9 is coming again and again, isn't it? So only one number is repeating. So if only one number is repeating, then okay, firstly you have to catch x. You have to consider that this number is equal to x. Okay, just to consider that x is equal to 0.9999. Okay, so now you can see that only one number is repeating. If only one number is repeating, then you have to multiply both sides of the equation by 10. Two numbers are repeating, multiply by 100. Three numbers are repeating, multiply by 1000. So as we have already discussed, because one number is repeating, so we will multiply by 10 on both sides. This side, on the left hand side, if we multiply by 10, we will get 10x. This side, if we multiply by 10, I will get 9.9. Why? Because 0.9999 is this. So if you multiply by 10, this point will come from here to here. One place towards the right side, isn't it? So it will become 9.9. Understood? So here you see, if you multiply by 10, then this point will come from here to here. Will come up? So 9.9 bar. Now 9.9 bar, can you write it this way? 9 plus 0.9 bar. Now in place of 0.9 bar, what can you write? In place of 0.9 bar, what can you write? Instead of 0.9 bar, you can write x. So write here x. X will be on the left hand side. So 10x minus x will become 9x. 9 is multiplied with x here, isn't it? 9 is multiplied with x. If you take it to the other side, it will get divided. So therefore x is equal to 1. Therefore 0.9 bar is equal to 1. Understood? 0.9 bar is equal to 1. Now, are you surprised by the answer? 0.999 became equal to 1. No, we are not surprised because 0.99999 is approximately equal to 1 only. we are not surprised. Is it okay? So students, let us continue. So number 6 now. Look at several examples of rational numbers in the form p by q. Look at several examples of, just look at the question number 6. Okay. Look at several examples of rational numbers in the form p by q where p and q are integers with no common factors other than 1 and having a terminating decimal representations. Can you guess what property q must satisfy? Can you guess what property q must satisfy? First we have to look at several examples in the form p by q and also having terminating decimal. Okay. And also p and q must have no common factors other than 1. They must have only one common factor. P and Q must have only one common factor, that is 1. Okay. So example 1 by 2 is equal to suppose 0.5, 1 by 5 is equal to 0.2, then again 13 by 10 is equal to 1.3, 23 by 100, 0.23. See here students. See. All the numbers are in the form p by q, isn't it? These are all rational numbers 1 by 2, 1 by 5, 30 by 10, 23 by 100. Rational numbers in the form p by q. And here, what is the common factor of 1 and 2? 1 is equal to 1 into 1, 2 is equal to 1 into 2. So what is the common factor? 1. In the question it is said that p and q must have only 1 as their common factor. What is the common factor of 13? 1 into 13 and 10 I mean 1 into 2 into 5. So what is the common factor? Only 1. Understood? So these two numbers, p and q, here also these two numbers, we have only 1 as their common factor. Now, and also all these examples that I have given, all are having terminating decimal representations. Okay. Now, what is the property of q that must? What is the property that q must satisfy? This is of the form p by q, p by q, p by q, and p by q. What is the property that q must satisfy? The property that q must satisfy is that the property that q must satisfy is that the prime factors of q are 2 or 5 or both 2 and 5. So, see students, what is the prime factor of 2? What is the prime factor of 2? 2 is equal to 2 into 1. What is the prime factor of 2? Only 2. What is the prime factor of 5? 5. What are the prime factors of 10? 2 and 5. What are the prime factors of 100? Prime factors of 100 students? 100 means 2 square into 5 square. Isn't it? 2 square and 5 square. So what are the prime factors? 2 and 5. So you see the property that q must satisfy. The property that q must satisfy is that the prime factors of q must be either 2 or 5 or both. Understood? Prime factors of q must be 2 or 5 or both 2 and 5. Okay. So you must remember this thing. Whenever a number has a terminating decimal representation, the prime factors of the denominator, that means q, p by q form, no? The prime factors of the denominator will always be 2 or 5 or both 2 and 5. Apart from 2 and 5, if any other factors come there, then it will not be a terminating decimal representation. Is it okay? So this is the thing you get to learn from this question. So this was the question. You see, look at several examples of rational numbers in the form p by q, where p and q are integers with no common factors other than 1. With no common factors other than 1 and having a terminating decimal representations. Okay, and having terminating decimal representations, can you guess what property q must satisfy? Okay, all the rational numbers that we have considered, are in the form p by q and all are having terminating decimal representation. Okay, okay students. And also one more thing they have mentioned is that in the question that P and Q must have common factor only 1. So what is the common factor of 1 and 2? Only 1. 1 and 5 only 1. What is the common factor of 13 and 10? Only 1. 23 and 100 is also 1. So now in this case, what is the property that Q must satisfy? The property, this is of the form P by Q, isn't it? The property that Q must satisfy is that the prime factors of Q will be 2 or 5 or both 2 and 5. Okay? Next, students, let us come to number 8. Let us come to number 8. Number 8. Find three different irrational numbers between the rational numbers 5 by 7 and 9 by 11. Okay. So 5 by 7. 5 by 7. 5 by 7, you see 5 will divide 5 by 7 means 5 will divide by 7. Okay, 7 0.07749 1071 7 307 4 28 207 2 40 60 7 8 56 40 7 5 35 5. Okay, so this will be 0.714 0.714 285 714 285 so 0.714 285 bar. Okay, so next one is, next number is 9 by 11. 9 by 11 is equal to 9 11 0.08 times 88 20 1 times 11 9. So 0.8181 81 bar. Therefore, three different irrational numbers between 5 by 7 and 9 by 11 are 0.7202 0.7303 and 0.7404 004 004. So students, we have to find out three different irrational numbers between 5 by 7 and 9 by 11. So 5 by 7, how will you find out? We divide 5 by 7. Okay, we are dividing 5 by 7. So this is the way we divide. We are starting with 5 and 3. When we are dividing 5 by 7, we are starting with 5. Once again, when you get that 5, you stop there. Understood? That means we are starting with 5 inside and 7 outside. So as you keep on dividing, first 7 will go how many times? 5 0 times. So you give 1 point here, 1 0 will go automatically. 7 will go how many times? 7 times. 7 7 are 49 minus 1 0. 7 will go how many times? 10 1 times. Like this, you keep on going. So once you get back to 5 again, you started with 5. When you get 5 again, you stop there. So the answer will be 0.714285. Again, you see, again if I give 1 0 here, because after the point 1 0 will come automatically. If I give 1 0 here, again 7 will come out, 7 7 is 49. So this set of number will repeat 714285. Okay, so that's why I wrote here 0.714285 71425. It will keep on coming. 71425 0.714285 71425 will keep on coming. This set of number. Okay, so So therefore I get this bar. You see, 0.71425 bar. That means this 1, 2, 3, 4, 5, 6. These 6 numbers are repeating again and again. Again 9 by 11 we are finding out. 9 by 11 also. 9 by 11 also we are finding out is 0.81 bar. Okay. So now 3 different irrational numbers between 5 by 7. 3 different irrational numbers between 5 by 7 and 9 by 11 are. Let us find out. So after 0.71425, after 0.71 next 72, isn't it? 0.7202002002. Okay. This is what is the kind of decimal expansion an irrational number has? An irrational number has a non-terminating and non-recurring decimal, isn't it? Non-terminating and non-recurring. So this is the kind of number. This is 0.7202002002. Again 0.7303003003 like this, and 0.7404004004 like this. Okay. So see, these are the, again more you can write 0.7505, 005, 0005. Okay. So only the thing is that whatever number, these three numbers must lie between 0.714285 bar and 0.81. Between this number and this number, these three numbers must lie. Okay. Again more examples are there. 0.7505, 005, 0005. Again 0.76, 06, 006, 0006, 406, like that. Okay. So students, next let us start number 9. Number 9 let us start. So classify the following numbers as rational or irrational. You have to classify whether they are rational or irrational number. Okay. So number 1, 23. This number will be rational or irrational. You know that students, if a square root of a square number only will be a rational number, such as root over 4 will become 2 is rational number. Root over 9 is 3. Root over 16 is 4. This kind of square roots will only become a rational number. Otherwise, it will become irrational. 23 is what kind of number? 23 is a prime number. It is not a square number, isn't it? So root over 23 is an irrational number. So we will write here since 23 is a prime number, therefore it is an irrational number. Okay. So again, number 2 you see root over 225. Root over 225. 225 factors you find out. Find out the factors. So 5 4 times 3 also you can do. 3 7 times 21. With 3 7 times 21. 3 25. 5 5. So 3 into 3 into 5 into 5. Is square into square. 3 into 5 is equal to 15. Therefore, the product of 25 is a rational number. Again, number 3 is 0.37, 0.36, 0.3796 is equal to 3796 after 1, 1, 2, 3, 4, 1, 2, 3, 4, 6. It is in the form 2 by 2 square. Interior and 2 is equal to 0. Therefore, it is a So see students. So first one is root over 23. Root over 23. So as I said, 23 is not a square number. 23 is a prime number, isn't it? 23 is a prime. Since 23 is a prime number, therefore you can write root over 23. Root over 23 is an irrational number. Okay. And root over 2 to 5. I found out the factors of 2 to 5. 3 into 3 into 5 into 5. 3 into 3 is 3 square and 5 into 5 is 5 square. So this square will go and the square root will go. The answer is 3 into 5, 15. So therefore 15 is what kind of number? 15 is a rational number, isn't it? 15, I said 15 is a rational number, isn't it? Because 15 can be written in the form 15 by 1, 50 by 3 form, isn't it? Therefore, root over 2 to 5 is a rational number. And here you see 0.3796. 0.3796. How many places before the decimal is there? This is what kind of decimal? Terminating decimal, isn't it? So 1, 2, 3, 4. 4 places before decimal is there. After 1 you write 4 zeros. So this is in the form. What kind of form this is? This is in the form P by Q, isn't it? So 3796 you see here 3796 by after 140. This is in the form what kind of form? This is in the form P by Q, where P comma Q are integers and Q is not equal to 0. This is in the form P by Q, where P comma Q are integers. Here this number 3796 is an integer number, yes, and 10,000 is also an integer. So this is in the form P by Q, where P comma Q are integers and Q is not equal to 0. So therefore, what kind of number this is? This is a rational number, or we can write therefore 0.3796 is a rational number. Understood? Understood? So students, this much only for today. So here in this big number 9, we only have to classify. Okay, we only have to tell whether the number is a rational number or an irrational number. Just give a reason and just write it down this way. Okay. So this was only for today, students. We will continue with our online classes. Thank you and have a nice day. Please see these things carefully and note down in your classwork copies. Okay. Thank you. Have a nice day.